minus x10. Yeah. And maybe Alright, for number 1, you needed to solve this equation. So distribute first. You get 6x plus 6 minus 3x equals 6 plus 3x. Combine your like terms. Remember, you're doing whatever it says, so 6x minus 3x would give us 3x plus 6. If you remember your rules for solving equations, these have the same constants, so the number by itself, and the same coefficients on both sides, which means it's a special type of solution. What was that solution? Infinitely many. So you could have stopped there if you remember that. Do you want to make sure your mask is up? Or you could have kept solving and you would have got either 6 equals 6 or 0 equals 0, and you would have got that same answer, infinitely many solutions. Questions on number 1? For number 2, you needed to find the domain and the range for this. Remember, your domain is furthest left to furthest right. Furthest left here would be -3. So we're going to start off with the curly brackets, x line for domain, y line for range. It's going to start at -3, and it goes all the way to +2. That's going to be -3 is less than or equal to x, which is less than or equal to 2. And then for your range, we're looking at the lowest point to the highest point. So the lowest point would be at -1 is less than or equal to y or f of x, either or. And the highest is 3. Yes. Questions on our domain or our range? For number 3, we needed to cross multiply in order to start solving this. So you could have went ahead and actually multiplied everything. I'm just going to write it out first. Oh, I wrote it wrong. Doesn't matter which side they're on. Then distribute and solve. Here we know that we're going to get one solution because our constants are different and our coefficients are different. Take whatever you want to move and move it. Let's say I move my 6a over by subtracting. Then I have 2a minus 8 equals -36. Then I can move my 8 over. My brain is funky. What is that?
-20.
And then divide. Questions on number 3? Yes, Kate.
Kind of shows kind of like a fraction. So.
The y there, I'm not really sure. It's just a different way to write an equation. As a proportion, proportions are technically can be written as equations, but we solve it just the same. Number 4, we need to evaluate. So that means take f of 9. We're going to put 9 in for x. So 7 plus 9. That's going to give us 16. The square root of 16 is 4. And 2 is right next to it. So we're multiplying. We get 8. So you can say f of 9 equals 8. Or f of x equals 8. Either or.
I have a question.
Yes.
Why would you multiply?
What do you view when two things are next to one another?
Which is what?
Are next to one another. Okay. They're next to one another, so we would multiply.
16.
What's the square root of 16?
4.
So that's what we got 4.
But there's a 2.
Right. The 2 didn't change. I just brought it down. So I was only dealing with what was inside. So I did the square root of 16. And then I multiplied it by 2.
Oh.
Number 5, we need to distribute. We have a bunch of fractions. So if you did this in your calculator, I would have simplified it for you if you use alpha y equals. So here we have 5 over 4x plus 4 over 3 minus 1/2 x minus 1/3. Those are the simplified answers. If you multiplied it as is, you would need to simplify. And then you could combine like terms. So we have 5/4 and 1/2. You could do that in your calculator or get common denominators. So this would give us 5 minus 2 over 4 is 3/4. And then because these two have common denominators, we can just subtract across. 4 minus 1 gives us 3. And that simplifies to just 1. So we have 3/4 x minus 1, I'm sorry, plus 1 equals -5. So all the fractions we had have condensed a little bit. And then we could just solve this for x. We subtract 1 on both sides. You can either divide both sides by 3/4 or multiply by the reciprocal. So this would be -24 over 3 or negative. There was a lot in that one. So could you do a lot of that by hand? Sure. You could also use your calculator as well. Yes. Actually, let me say this next part and then I'll write your task. Any other questions on the short way? So before we get into what we're going to get into today, there's a couple things that I wanted to talk to you about. One, everyone has a course calendar, the gold course calendar on your desk. But when those were made, I made them in December before we had a week off of school, so all the dates are now different. So if you use those and want to change those, I'm gonna say what the new dates would be. The content is really the same, just the dates are changing. So today is the 11th, and we're gonna do the solving systems by graphing. On the 13th is going to be the solving systems by substitution. On the 18th, because of Martin Luther King Day, is going to be solving systems by elimination. The 20th and the 24th are both going to be solving systems of word problems. The 26th is going to be a review day. And then the 31st, because the 28th, you guys don't have school because this is teacher work day. So the 31st, which is a Monday, is you guys' tests. Anyone need me to repeat any of those dates? The 26th. Yes.
So the test was on January 31st.
Yes. So those should be updated in Canvas already. I've updated the board with that. If anything happens between now and then, I'll change those dates again. To also mean the Khan Academy that was due this week and last week have been updated. So some are still due this week, but not the same ones that were originally due. There it is. Along with that, I don't believe I said this before, so I'm going to say it now. I printed out you guys' progress reports. That is your grade that's going to show up on the report card for marking period 2, unless you take missing tests, come do retests, or turn in any missing Khan Academies, because nothing else is going in marking period 2. Everything we start today moving forward will be put on marking period 3. So when you look for those grades, look in marking period 3, do not marking period 2. I was still said to study for the SOL. I think it's I want to say Meg. Okay. Questions about any of that so far? Right, and then the very last thing, I spoke with most of you, I may have to still talk with some of you about recommendations for next year. If those are still the same, then that's what I'll be recommending you for. If you don't remember, we can have that conversation. If something has changed, or maybe what you and I thought you should be recommended for next year is different, hold on a second. We can revisit that conversation. Or if you change your mind on what you want to be recommended for, we can have that conversation. But just keep that in mind, because unless that changes or we have that conversation again, whatever I recommended you for and talked to you about will be the same thing. Yes.
Talk to people about this on Friday.
Yeah, when did you do that?
Because it was last Friday.
I know it was the last day before we were on break. I don't know if it was the day before that too.
I'll say so.
But I have a list of who I didn't talk to, so you may or may not be on that list. Michaela, I don't think you were on that list, for sure. Okay. Pass, and then I'm constantly losing things on my desk. I'm done. Everyone should have notes on their desks that look like this. We're going to start those today. Make sure you have them in front of you. Okay. I'm gonna show these notes because I don't remember exactly what this and then I'll read it off to you. Just in case you can't read it. So the definition for a system of equations, two or more equations with the same variables. So before we have solved equations to get like a solution, now we're going to be solving multiple to still find a solution. When we find the solution to a system graphically would be where the two lines intersect. Michaela?
On the orange sheet it says 6, unit 6, but that says 5.
Yeah, disregard that. It's unit 6. That's because last year it was unit 5, and I just didn't change it.
Instead of 6.1.
Yes. So graphically, it's where the lines intersect. Algebraically, it's the point that makes both equations true. So we'll see what those two mean here in a little bit. In the next 3 boxes, where it says intersecting lines, parallel lines, and same line, draw an x and y axis in all 3 of them. Draw an x and y axis in the next 3 boxes. So as we move forward, let me rephrase that. I would recommend that you start doing these in either 2 different colors, 2 different writing utensils, something you can tell that they're different. You could even use like a pencil for both, or maybe highlight one. For intersecting lines, you're going to have 2 different lines that intersect each other at some point. And that point would be your solution, x, y. There. What do we remember about parallel lines?
They aren't they're like a
They have the same slope.
cross.
They do have the same slope. Say that again, Peyton.
They're just a cross. They can't be like an X.
They
There
wouldn't,
won't be to intersect at all.
right, they wouldn't cross at all. So for parallel lines,
Oh, you're talking about parallel.
yes, not perpendicular lines. I think that's what you're thinking about. So for parallel lines, because they never intersect, that would be no solution. So you could write an S or 0 with a line through it. And then there's one last case that you might see where we have some equation that's graphed, and we end up having to graph over top of it because it's the exact same line. If we get a case like that, that would be infinitely many solutions. I don't know what it is for. Or you can write the infinity symbol. These are the only types of solutions you can have for systems of equations. One, where they cross at some point. None, where they don't cross at all because they're parallel lines, which means they have to have the same slope. Or the same line, where they would cross at every single point along the line, meaning they would have the same slope and the same y-intercept. I'm going to show you the steps for solving the system. So step 1 is rewrite the equations in slope-intercept form if they're not in that already. Step 2 is graph the lines. This is what that should say. Lines. Yes, Erica. Yes. Can you wait like 5 minutes? And then step 3, identify the solutions. So after you graph it, you should be able to see whether it's one, none, or infinitely many solutions. Alright, so I'll give you another minute. Here, so you can go now. Anyone still need these instructions? We're going to do a few examples together, then I'll let you try some. So let's start with number 1. I'm going to do these in 2 separate colors, that way you know which ones are which. In order to graph a line, well first, let's backtrack. If I'm looking at these 2 equations, would these 2 lines be parallel? No, they don't have the same slope, so I can get rid of or eliminate no solution as one of my answers. Would these be the exact same line? No, they don't have the same slope, they don't have the same y-intercept, so infinitely many solutions could not be an answer. So this has to be one solution. We just don't know what that solution is, so we have to find it. So for this, in order to graph this, where would I start? What would I plot first? -8 for my y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. If you have rulers in a colorful card, if you want one. And then we need to plot our slope. Plot as many points as possible along your graph. Fill up your graph completely. Your slope here is what? 1. And it's positive. What directions could I go to get a positive slope? Up and right. So go up 1, right 1 as many times as possible. What other directions could I go to get a positive slope?
Down.
Down and left. So go down 1, left 1 as many times as possible. Once you have all of your points, you can connect the dots, make a line. Make sure you have arrows on your line. And then you can draw your other one. This one would have a y-intercept of 1 and a slope of -2. What directions would give me a negative slope?
Downward, up to the left.
Up and left and down and right. So up to right one as many times as possible and down to right one. I think I said that backwards. Up to left one and down to right one is what I meant to say. As you plot your points, you'll probably see the point where they cross. Still fill out all of your points and still make your line. Yes, Lily?
How did you? So you have the y is 1, so you know that's where we got our starting point.
Mm-hmm.
Why? How did you?
The slope is -2 over 1. So we're going to go down 2 to the right one or up 2 to the left one. Where do these two lines intersect?
Down 2 to the right one.
This is slope, yes. What is your solution here? -5. So you would put that in parentheses to show your solution. Do we have any questions on how we found that answer, graph the lines? We're going to jump to the back of this page. And we're going to do 4, 5, and 6. It was 3, -5. For number 4, we would need to solve this one before we do anything else. How would we get this back into slope-intercept form? Add x and subtract x to both sides. So we have 2y equals, I'm going to go ahead and switch these two so that it starts to look like y equals mx plus b. And then what?
Then divide 2.
Divide everything by 2. So our new equation is y equals -1/2 x plus 2. Before we graph these, look at these two equations. What do we notice about them? They're the same, which means this is going to be what type of solution? Infinitely many. Even though we found the solution, we still have to graph this because we are solving it by graphing. So we will start at +2. Our slope is -1/2, so we can go up 1 to the left 2. As many times as possible. And down 1, right 2 as many times as possible. Now, because these are the same line, you can do a few different things. You could graph on top of this one in a different color. You could highlight over this one in a different color to show that there are two different lines there. Or you could just take your, whatever you're writing with, and at the end, draw like double arrows to show that there's another line there. Something that lets me know that you know that there are two lines there.
This works. And I just like highlight.
Questions on number 4? Moving on to 5. I'm going to focus on this one first because that one will be easier. Remember that if you have an x equals a number or a y equals a number, it's going to be a horizontal or vertical line. Somewhere on your paper, write this toy box, just in case you forgot what that means. So remember that is horizontal lines have 0 slope and are y equals. Vertical lines have undefined slope and are x equals. So y equals -7 is going to be a horizontal or vertical line? Horizontal. So we're going to make this a horizontal line at -7. And before I solve the other one, I know a couple things. These are not the same, so infinitely many solutions is out. And then these don't have the same slope because this one has an x and a y, this one just has a y. So these can't be parallel either. Solving this one, we would get rid of x by subtracting. And divide everything by 3. This is -1/3 x minus 5. So our y-intercept would be at -5. Our slope would be -1/3, so we can go up 1 to the left 3 as many times as possible. And down 1, right 3 as many times as possible. To make that one. Again, just in case you missed what the equation was, y equals -1/3 x minus 5. What would our solution be?
6, -7.
6, -7. Any questions on that one? Okay, and then 6 will be the last one we do together on this. So I'm going to solve this one first. Subtract x on both sides. What would I be dividing everything by? -1. To get y equals x minus 2. What did we notice about these two lines?
Same.
They have the same slope, which means what for the solution? They are parallel, which means what? NS or the 0 with a line through it. So this would be at -2, slope of +1. And then the other one would have a minus up to 5 with the same slope. Do we have any questions on how we solved any of these so far? I'm going to give you the next 10 or so minutes to go back and do number 2, number 3, and then 7 and 8, and then we'll come back and we'll talk about it. Your answers. So for number 2, I know it's a little small. Really focus on, do your lines look like they look up here, and is the solution the same? So for number 2, this first one should have been a positive slope. The second one was a negative slope or a negative line. The solution was -2, 8. For number 3, the first one, the equation should have been y equals 3x plus 8. So a line that looks like this. And then the second one was y equals x minus 2. So a line that looks like this. And the solution was -5, -7. For 7, you had to solve both of those again. The first one was y equals 3/5 x plus 7, and would have looked something like this. The second one was y equals -2x minus 6, and would have looked something like this. With a solution at -5, 4. And then the last one, x equals -2, should have been a vertical line at -2. It's a little off here, but it should be at -2. And then the second equation was y equals 3/2x plus 9, so that would have been this line right here, with a solution at -2, 6. Do we have any questions on any of those? I want you to find the page that looks like this. So this is a really good way to check yourself. Let's say you find a solution after you've graphed it, but you're not sure if that's right because it doesn't look like it should be right, or maybe something was up, I don't know. So we're going to do a couple of these. If we are given a solution, or if we find a solution, we want to check it. Well, first, if we had just a regular equation, we found an answer, how would we check to see if that's right or not?
The inverse operation.
if we were solving it for. But let's say we already solved it and we got an answer. How would we check to see, is this answer correct?
Solve the equation correctly.
Yes and no. Let's say we already did that. We already solved it.
For x, or for incorrect.
We can put it into our equation. If it works out that it's a true answer, the answers match up, then that's our answer. Same thing here. So I could put this 3 in for my x, the 2 in for my y, and see, does this become a true statement or not? If it is, it's a solution. If it's not, it's not. But it has to work for both. So if it works for one and it doesn't work for the other, it's not a solution for the whole thing. Or if it doesn't work for either, it's not a solution to the whole thing. So let's do this. For this first one, our y is 2, our x is 3, so negative 1/3 times 3 plus 3. We could simplify this and see, do both sides equal? So this would be 2 equals negative 1/3 times 3 gives us negative 1. Negative 1 plus 3 is 2. 2 equals 2, so this is a true statement. But just because it works for one doesn't mean it's a solution to the entire thing. We still have to check the other one. So we're going to do the same thing and put 3 and 2 back into x and y for the second equation. So we would get 2 times 3, which is 6. 6 minus 4 is also 2. So that works. So I can say that because it is true for both, this is the solution. Or if we graphed it and we got that answer, that is our actual answer. For number 2, let's try the same thing. Scratch that. Let's do 4 instead. These are in standard form. You do not need to change these to slope-intercept form to test this. You can test it just as it is. So if I put in 5 times negative 2 minus 2 times negative 1 equals negative 8, I get negative 10. Negative 2 times negative 1 is a positive 2. Would this give me negative 8? Yes. So that one works. Let's try the other one. 3 times negative 2 plus 2 times negative 1 equals negative 8. So here we have negative 6 minus 2 equals negative 8.
Yep.
That would also be a true statement. So I can say this is a solution. In a minute, I'm going to let you try the other two, but first look at the bottom 4. These are now, they're graphs for you, and you have to state what the solution is. For 5, what would that solution be? Negative 2, negative 1. What about for 6? Negative 1, negative 1. I want you to take the next 5 or so minutes to do the remaining problems on this page. Not the question. To this one. So do numbers 2, 3, 7, and 8.
After she's done, you scroll down again, where the 2 points you put the answers.
Yes. Oh, it actually says state the system too, but we're not going to do that part. Okay. For number 2, that should have not been a solution. It didn't work for one of them. Number 3 should have also not been a solution. It didn't work for one of them. Do we have questions on either of those two? And then 7 was 3, -1, and 8 was -4, -2. The very last thing I'm going to show you today is how you would check this on your calculator. So I'm going to put one of these into desmos and the other one in the calculator to show you how they would both work. So I'm going to put 3 in desmos just so you see how that would look. What's nice about putting these in desmos, and I think I said this before, is that you don't need to solve this. You can put it in as is. Of course, I don't remember what those said. So before you guys start packing up, we are going to do one in the calculator. Hold that on. So I could type this in exactly as is. X minus 3y equals -15. And 9y minus 3x equals 45. So I don't know if you guys saw what just happened, but it looks like they line up over top of one another. To double check to see if that happened, press your gear wheel and change the type of line to like a dotted line for one of them. And you can see the red line is behind the blue line, so they are in fact the same line. So they would have infinitely many solutions. If it was one solution, it would show you where they intersect. So let's say I change something here. It would show you where they intersect, and you could click on that point, and it would show you the intersection point. And then really quickly, I want you guys to put this in your calculator. So stop packing up. Put your hands in your calculator. Reset it first, second plus 7, 1, 2. And we're going to put number 4 in. Go into y equals. You're going to put the first one into y1, the second one into y2. Negative x minus 6 and 7x plus 2. Negative x minus 6. Once you have both those in there, you're going to hit graph. Oh. When you got them, a couple of different things will happen. One, you'll be able to see where the two lines intersect, and you can probably count up to that point. 2, you can't really see where they intersect because it intersects off the screen, so you have to zoom out to find that point. 3, maybe it looks like it intersects exactly at that point, but you're not sure. Maybe it looks like it's going to be a decimal, maybe it's on a decimal, and you're not sure. To figure out what the intersection point is for certain, you're going to do this. Go into second trace. And what do you think we're going to look for? Where they intersect. So 5. When you hit 5 or intersect, you're going to get this first curve. It's just talking about your first line. It should be on the first line, so hit enter. Second curve should be your second line. It should be there, so hit enter. Then it's going to say guess, like do you want to move to where you think the intersection point is? You don't want to do that, just hit enter again. And it will tell you what the intersection point is. Okay. So desmos and your calculator are really good ways to check yourself as well as putting it in and solving it. However, I just want to mention this, and I'll mention it again later. If you use this to find your graphs, you still need to graph it by hand. So you could use this to make sure your graphs are right, or use this and like copy down the graph, but you will still need to copy down the graph or graph it. You guys